Hello everyone. In today's video, we'll be talking about how to create an AI in Unity. So here in our scene, I set up a few objects as well as our plane and this little capsule here who's gonna be our NavMesh agent. So first, let's set things up. So first things first, we need to download the AI navigation package from the package manager. So we'll go here to Window, Package Manager, and in Unity Registry, we'll be searching AI navigation. There. I have this installed here already, but if it isn't on yours, kindly install it into your project. Next, we'll have to set up our NavMesh agent. So for NavMesh agent, there are a few things we need. So here you can see on default, we have the mesh renderer as well as the capsule collider. What we need to add here is firstly a rigid body so that our NavMesh agent will be able to collide with things. We're going to freeze the rotation of X and Z, set collision detection to continuous, and set this rigid body to kinematic. Then after that, we'll be adding a NavMesh agent. There. This outline here, you can see around our capsule is the NavMesh agent. And here you can check the agent's actual height here. Here you can see the height, the radius, as well as the speed that you can set him to. So now that we have our NavMesh agent done, next we have to make a NavMesh surface. Our NavMesh agent relies on NavMesh surfaces to allow it to walk around in the world. So we're going to have to add here on the ground component, we're going to add component NavMesh surface. Yeah. Keep note, I'm on Unity 2022, so depending on whatever version you have, NavMesh might be in a different version. So here in NavMesh surface, all we have to do is click bake, and there you go. This blue outlines that you can see here, this is the path that our NavMesh agent can walk on. So you can see here on this slope, the blue panel goes over, as well as on these stairs, it goes over. You notice as well, even if we didn't put the NavMesh surface object on the other objects, it still bakes everything in this area as a patrollable area. So there are two things that we need to consider in navigation. If you go here to Windows, you can see here the AI bar here and open up navigation. We'll go to the navigation window where you can set different agent types, set their name, the radius, height, the step height, and the drop and jump distance. There are three core things that we need to focus on when dealing with AI, which is going to be the agent radius, the height, and the step height. The radius dictates how wide our NavMesh agent is and how far it should be from objects so it won't collide. I've set this to 1 so that we have much more space between different objects. But if I change the value here to, let's say, 0.5, and then bake that again, you see that the space here becomes a lot narrower. 2. Okay, let's do a more extreme example to 2. And you see, this is the NavMesh's obstacle avoidance. Yeah, considering its size, it's going to automatically create a margin around every obstacle so that they'll be avoiding it from there. Let's set this back to 1. Now, height is another interesting thing. Depending on your agent's height, they will not be able to go through certain things. Okay, so we have here this giant box with a smaller space underneath it. I'm going to bake it from the ground object. There, you can see with our agent's current height, he'll be able to walk underneath it. But if we raise up our NavMesh agent's height to, let's say, 5, and then bake it again, you see that NavMesh surface immediately clears this area because it considers the NavMesh agent too tall for this small area. That's what height does. So let's set it back to 2 and make it once again. So next, let's talk about step height. So step height here talks about how high the NavMesh agent can take a step. So particularly, it would be talking about like stairs or other walkable things. So we have here the stairs, and I've set the step height to 1. If I will lower that to, let's say, 0.5 and make that again, you'll see now that because I've set the step height to 0.5, the NavMesh agent won't be able to walk on top of the stairs because its step height is too low. And if I get back up to 1, there, the NavMesh surface bakes again on top of these stairs, allowing our guard to walk up the stairs. And another thing is slope. This max slope represented here. This max slope talks about up to what angles can our NavMesh agent walk up on. Now this here, this particular cube is set at a 45-degree angle. So if we were to change our slope height to, let's say, lower than that, let's say 10, and we are to bake it again, you see here, now our agent won't be able to walk up this slope because it's too steep for the NavMesh agent. Then if we set that beyond 45, let's say 50, there. The NavMesh agent will still be able to go up. As long as the value of the slope is lower than your slope height, the NavMesh agent will be able to walk on top of it. So let's pick that again to revert things. Okay. Now first things first, we want our AI here to walk around to a certain point. So let's say we want our NavMesh agent to walk around here. To do that, first we need to create an empty object here. And we're going to call this point 1. So let's go here lang just so that we can visually see where this point is at. And let's bring it back up to the ground. Okay. And you see here this dot. This is where our empty game object is currently at. So let's say we want our NavMesh agent to move over here, just here. There we go. So to do that, we'll need to add in a code that sets our NavMesh agent's destination to here. So let's create a new script. We're going to call this AI controller. Let's open that up in Visual Studio. So here in AI controller, first we need to call our private mesh agent. And we're going to call this agent. So after calling our NavMesh agent, we're going to add in the new header here. And we're going to call it movement. And right under it, we're just going to call public float speed walk. And let's set this to default 3F. And we're going to need to get the position of our empty game object. So we're going to do public transform destination. Okay. So now that we have these, once again, since we put our agent component into private, we're just gonna retrieve it using void awake. Void awake agent equals get component NavMesh agent. So here in update, we are going to want our agent to move to our destination position. So to do that, we're going to add two new function that we're going to call private void move. I'm gonna call private void move as well as private void stop. Okay, now that we have these two functions, move and stop, we're going to, here in move, we want to set our agent speed. We want to set our agent speed to our current speed, which is speed walking. So here in move, we're just going to simply do agent dot speed equals speed walk. It's that simple. Because you can see here, if we go back to Unity, our NavMesh agent already contains a field for speed here. So all we need to do is to set our speed through script so that it's easier to adjust. Then here in stop, what we're going to do is we're going to set our agent speed to 0 and call agent dot is stop equals true. Now, what this agent is stop does, it essentially tells the NavMesh agent to just stop in its place. After that, we're going to say agent dot auto braking equals true, true. There. Auto braking, if you see the description here, it automatically stops the NavMesh agent from overshooting the destination point. So yeah, we're going to set that to true here and stuff. And in move, we're just going to do the opposite so that our agent can continue walking. So agent dot is stopped equals false, and agent dot auto braking equals false. Now that we have our basic movement functions, we can call that here in update. So what we want our little guard here to do is that when our point is here, we want him to walk towards that point, and once he's close enough, we want him to stop in place. It doesn't have to be right over it. Let's let him stop. So first step, we have to make our agent move to the destination. So we're going to say agent dot set destination to our location, which is here in destination in our destination object. So destination dot position there. That way it will keep moving towards wherever the point is. And once it gets close enough to the point, we want it to stop before it gets right over it. So what we want to do is we're going to say if agent dot remaining distance is less than or equal to agent dot stopping distance, we want agent to stop. If not, we want our agent to continue moving. So move. So what agent remaining distance does, what this thing does here, it gets the agent's current position and its target position here. Does something similar to what vector 3 distance does. Essentially, it calculates the distance between our agent right here and its target position. And if that remaining distance becomes less than or equals to the stopping distance where we want him to stop, we're going to call stop. That way our agent will stop right in its tracks. And now we can test it in Unity. Here in Unity, let's go back to guard, and in the inspector, let's add in our new script here, AI controller. There. And this destination field here, we're simply just going to assign our point there. That way it will get our point location. Now let's save that. And don't forget, we also need to set our stopping distance so that our agent will know when to stop. So let's put it to, let's say 2. We have much more leeway. Okay, let's play that and let's see if it works. There you can see here, while you select your guard, you can see this orange icon over here is where NavMesh sets its destination to. And you see before our guard even gets right over it, he stops right there because the distance between him and the point right now is around 2f. We were to move this point away from our guard, let's say over here, he's going to automatically move towards wherever that point is. Okay? He's gonna keep walking around until he gets close enough to the point and stops. How does this guard keep moving to this point? It's because we put our function here in update. Now you see here in update that because we put our set destination to update to update every frame, that means even if we move our destination object, it's going to keep moving to wherever its new position is because it keeps updating. Now that we have that function ready, we can now set up our patrol system. Now we want our AI over here to walk to different points and cycle between them. So let's say we have point A over here. Sorry, let's have point A over here. We create a new position here. Let's call that point B. And a new position here, we put that point C. And we want our AI to move first to A, then to B, then to C. Sorry, then to C. And we want him to move back to A. So how do we do that? Well, like earlier, we need to get their different destinations, but this time we're going to use an array. So we're going to use an array so that we can hold the different positions of our patrol. So let's set up that first. Let's have here point A, point, well, let's call this A, create another one, put it up on the stairs. We'll call this B, and make another one, and we'll call this C. There we go. Now we have our 3 points, and now we can edit our script again. So we can add in the patrol function. So now that we want to add in our patrol function, what we're going to do is we're going to turn this transform here into an array so that it can hold multiple destination objects. And we're going to add in a new public int that's going to be called destination index. What this is going to do, it's going to hold the current destination for our AI. So here in array, we have 3 elements, but the positions here are different. In arrays, with your first object, you always start with 0. Then you go 1 and then 2. What destination index is going to hold? It's going to hold the value of the current object that we want to go to. So let's say if we want it to go to point C, all we have to do is we're going to set this to 2, and it's going to get 2 here from the array destination. So here, our next point function, what we want it to do, we want it to go to the next point. We want our agent, once it gets to a certain point, we want it to shift to the next point in the list. So how we're going to do that, we're going to call destination index plus plus. What this is going to do, it's going to simply add 1 to the current value. So in order to cycle our positions from the max value back to our first element, we're going to call if destination index is greater than or equal to destination.length. Why destination.length? What length does for an array, it returns the number of elements in the array. Now, elements and positions are different. This here, this 0, 1, 2, these are positions or index. Elements, however, is the actual number of items that are inside the array. So what length is going to return here in this example is going to return number 3. Why? Because we have 3 different elements within that array. So once we hit the number 3 here, we want destination index to go back to 0 so that it doesn't produce an error and go outside of the group. And so in order to do that, simply once it goes past the length or equals that length, we want it to set destination index right back to 0. That way it will be able to cycle back to the first element. Right after that, we want to set our agent destination to our current destination. Destination index dot position. And we'll call move. Sorry, let's call move first. Yeah, there. Now, in order to handle this next point, we're going to put it inside our patrol function. Remember earlier our stopping functionality in update? We're going to add that back here in patrol. So we're going to do if agent not stopping this, that remaining distance, sorry, is less than or equal to agent dot stopping distance. So once our agent reaches close enough to the point, we want it to go to the next point. So next point. There. Else we want him to continue. Sorry, wrong symbol. Else we want him to just keep moving. There. Let's call stop here. Yeah. Before we go to Unity, let's add our patrol function here in update. So that it will be called every frame. And to initialize this patrol, we're going to do here in start. We want to set our agent's position, set destination to our first destination. So destination index, that position. There we go. Now, if we press play, our agent should go first to point A, which is here, point B, and then point C. Now let's play that. Let's see. There, you can see our NavMesh agent sets its destination to our current A, and once it gets close enough, it immediately goes over to the next point. The same with the others. There. Also, if ever you encounter the problem wherein your NavMesh agent gets stuck on a small item or like stairs, which it's supposed to walk over, like here in this example. Yeah, you can see our NavMesh agent here is having a hard time walk up. All you have to do is turn on kinematic, and that should stop uh, gravity from pulling this guy down because the NavMesh surface already handles gravity and lets it walk across the path. So we don't really need uh, gravity or much physics. We just want him to move. Essentially, what rigid body here does is it just provides contacts or like collisions and etc. So as you can see here, our agent currently moves from point to point, but it would be better if our agent stops at each point, right? It would be better if our agent waits a moment on the point and then decides to move over to the next point. So in order to do that, we'll go back to the scripts. Here, we'll go back to our scripts. And here we're going to add in a new public float that we're going to call start wait time. And our private float current wait time. Now, what we're going to use these two for is essentially current wait time is going to be our timer to tell to tell how long our agent should wait. So timer for waiting. And let's just initialize it to, let's say, 3F. All right. So here in start, we're going to set our agent's wait time, current wait time equals start wait time. Again, why did we separate start wait time from current wait time? Current wait time over here is going to act as our variable that keeps changing. And once the wait time is over, we want it to set back to the original time. So that's why we separated start wait and current wait. So back here in Patrol, what we're going to add here is if current wait time is less than or equal to 0, we want him to uh to move over to the next point and reset our current wait time back to start wait time. Else, we're simply just going to stop and subtract current wait time from time dot delta time. Time dot delta time is essentially the real time as a function. So what it's going to do, it's going to slowly subtract the current wait time until it reaches 0 or less than 0. And then it's going to move over to the next point. Now, let's test that out back here in Unity. Let's save that and test it. And if we press play, we should see that once the agent gets close enough, he's going to stop for a moment and then move over to the next variable. Oops, sorry, forgot to turn this on to kinematic. Remember, any changes you make while the game is playing, it's not going to save. So make sure that if you're going to add in changes, you have to stop the play mode and then put in your change. Our agent is going to get close to here, stop, wait for 3 seconds, and move over to the next point. There, stop, move again to the next position. Yeah, there. Simple as that. And it goes back to air. There we go. Okay, now that we have our AI patrol function, we want to add in a chase function which chases down the player whenever our player is near. So I have here Buck from our previous video. We have Buck over here, as well as the player controller and everything. If I press play over here and get close to our AI, he's going to just completely ignore the player at the moment and just keep going on its path. What we want him to do is whenever our player is close, we want Mr. AI over here to walk towards the player and chase him down. So in order to do that, let's go into our guard script. So here in our scripts, we're going to add in a few things. So here in movement, we're going to add in a new public float speed run. Now, what we want it to do here is whenever the player is close, we want our agent to change its speed to a higher movement speed to simulate chasing. We're going to add in a header here called patrol. So here, after adding those in patrol, we're going to add in a header, chase, and call public game object player. This one will hold the player object. Next, we have public float distance to player. What this is going to do, sorry, forgot the semicolon. This is going to do, it's going to hold the distance between the AI and the player. Next, we have public float chase distance, and we'll initialize that to 5F. Now, what this does, it's going to dictate the range of the AI's detection. Yeah, it's going to dictate the detection range of the AI. And we're going to add finally public bool is in range. This boolean here will tell the AI whether or not the player is in the detection range. Okay, now here in void await, we're simply going to retrieve our player object. So we're going to call player equals game object dot find game object with tag and then add in the string player. What this function here does, it scours all of the objects in the hierarchy over here and finds the first object with the tag player. If you look here back at Buck, I've added here the tag player, which you can find here. If you need any more custom tags, just click add tag here and yeah. But anyways, here we have Buck tagged as player. And going back to the script, after retrieving player, we have to go add in now our first new function. We're going to call detect. And what this does, it's going to simply update the AI whether or not our player is within chasing distance. So first, we're going to calculate the distance to the player. So distance to player equals vector 3. It's for in 3D, the vector 3 distance transform dot position equal comma player dot transform dot position. There. So what this is going to do, it's going to keep calculating the distance between our AI and the player. After that, we need a condition to check whether or not our player is in range. So if distance to player is less than or equal to chase distance, we want to return is in range equals true. And if not, we want to return is in range equals false. And we're going to simply call that here and update detect. There we go. After that, we want to add a function here that holds the behavior of our AI's chasing. So we're going to add here another one, private void chase this time. And under it, we're simply going to set our agent dot set destination to our player dot player's position. So player transform dot position. Now, remember earlier when we added a new speed run here? We want to switch over to our run speed whenever our AI is chasing and switch back to walk speed whenever our AI is patrolling. So we're going to go here in our move function and we're going to add in a new field here. We're going to call float speed. Now we want this to be customizable so that it's a lot easier to code later on. And since we updated this, we have to check every time this move is called here. See, in patrol, we have to add this speed walk. Here in next point, speed walk as well. Okay. And here in chase now, we can call move, feed, run. There. Now we want to call this behavior whenever our player is in range. So here in update, going to simply add a new condition. If player is in range, chase. Yeah, the AI will chase the player. Else, we want it to continue patrolling. There. Let's go back to Unity and check if this works out. Let's go to our guard over here. There. As you can see, we can add in now our player object down here. Save that. And let's go check if this works. So once I press play, there you can see our AI is constantly calculating the distance of our player from it. And if we move towards that AI, it's gonna lessen that number. And if we're close enough, there. Now our speed changes over to our speed run. And you can see our AI over here keeps running towards us. I'm gonna move behind it. There. See? It's gonna, oh my goodness. Gonna keep moving towards Buck as long as he's in range. And once I get out of there, right, stop. And he's going to go back to patrolling. Now, if you want to add in something that happens once your AI collides with the player, all you have to do is you go back here in our nav AI script. We're going to add him here down below on collision enter. We're going to change this to actor. And what we're going to do is once our AI collides with our player, we want it to trigger a game over sequence. So we're going to say if actor, which is this whatever collider it hits. So actor dot game object dot compare tag, and we're going to call it player. There. So if our actor game object has the tag player, we want it to call our game over function. Trigger game over. Or for this case, we can just simply do player dot game object dot set active false for simplicity's sake. Let's save that. Okay, now let's test that out here back in Unity. Gonna hit the play mode. And you can see here, if I get close enough to the our AI is gonna chase, and if I stop, whoop, he turns off my player. I can move. And that's gonna trigger game, that's our game over. So it's as simple as that. So thank you guys for watching this video. And now you know how to code a very simple AI. If you have any questions, comment it down below or send me a message in Messenger. That's about it. Thanks for watching. Bye-bye.